Okay, so hi, fifth hour. I want to talk about what's coming up this week. And then we do have a new lesson for today and tomorrow. So obviously this is the last week before Christmas break. Yay!
Merry Christmas.
That also means, right? That also means that all assignments have to be turned in by this week because your second quarter grade and your first semester grade, those both end as of the end of this week, okay? So we will do a new lesson today and tomorrow. We have an activity thing Wednesday, but on Thursday, I am giving class time in Zoom that if you are missing assignments or you're confused on any missing work, I will be here to answer questions. So Thursday is not a new assignment, but if you have missing work in science, you still need to come to our Zoom because I will be allowing that time. If you've been doing awesome, you don't have late work or missing work, then Thursday is kind of like a relaxy day for you. But a lot of us have work that we still need to turn in. And so that's why I'm giving Thursday for time to do that. So please, please take advantage of that. Okay, I'm gonna get us started with today's stuff. And I'm gonna teach you guys how we can calculate the speed of a wave. So, morning, Justin.
Warm-ups today or a warm-up test this week?
No, thank you for bringing that up. Because classes are only 30 minutes, I have been kind of not doing warm-ups or like building them into the lesson, but there won't be any warm-ups right down. Thank you. That's a good question. Classes are just too short right now to really do it. But that doesn't mean we won't be like reviewing from the day before, because that's actually what we're about to do right now. Okay, so today and tomorrow are about wave calculations. When you hear that word calculate, yes, it does involve just a little bit of math, but I know that you guys are math geniuses. It's going to be okay. In science, we like to call it SMAth, science math, but it's not going to be that bad. And there's only 4 practice problems on the worksheet that we're going to do, okay? But I want to review with what the heck are waves, right? We have all these different classes. It's almost Christmas. Our brain forgets. So in the chat for points for your group, extra credit points, I would like somebody to tell me waves are a transfer of what, okay? Waves are a transfer of, who can tell me in the chat?
Energy.
Okay, awesome. So when I'm sharing my screen, I can't always see you. Who was that told us waves are a transfer of energy?
Aaron.
Thank you, sir. Yes, that is correct. Okay, waves are a transfer of energy. So the movement, oops, I gave the next answer away. The movement of energy from one place to another travels in waves, whether it's sound waves, light waves, electromagnetic waves. Waves are a transfer of energy. And some waves travel much faster or slower than others. So I gave the example of light versus sound, okay? I want you guys to think about during a thunderstorm. So when it's raining and there's lightning and thunder, okay? We will see lightning, and then they say that you can tell how far a storm is from where you are by how long it takes for you to hear what? Who can tell me in the chat? So when there's a lightning and thunder, okay? So we see the lightning, and then we count how long until what? Good, Colton. Yeah, right, good job. Until we hear the thunder, okay? Well, what if I told you the lightning and the thunder are happening at the same time, okay? It's actually the same occurrence, but light waves travel 1,000,000 times faster than sound waves. So you see the lightning, and then it might be several seconds till you hear the thunder. That's because sound waves traveling through the air,
Wait, so what are we doing?
it takes that long for the sound waves to reach you. So right now, Tristan, you're just listening because I'm going over the speed of waves. So you're listening, and then I'm going to have you guys write on your worksheet. Okay. So I just said the magic word. If you heard it, but we can calculate the length of a wave. So what do we call that? How fast or how slow something is moving. Good job, Colton. Yep, speed. We can calculate the speed of a wave. Thank you, Trey. Good job, Draven. So that's what our focus is today. We learned words about a wave, right? Frequency, wavelength, amplitude. We're going to use those to be able to calculate the speed of a wave. Okay, so here I have two waves. I keep showing the answers. Okay, here we have two waves. The top wave and the bottom wave are traveling at different speeds. They have different something and something. Okay, so looking at these waves, which one, the top or the bottom, is a high energy wave? The top or the bottom? Which one is a high energy wave? Yep, good job in the chat. Thank you guys. The bottom wave is higher energy. Okay, we can tell that by looking at a couple of things. So now I can show that. Oh, I'm like click happy with my mouse over here. Okay, this top wave has a long wavelength. There's a lot of distance between the waves. Low frequency, so this is a low energy wave, okay? The bottom wave, okay, by contrast, the bottom wave has a short wavelength, high frequency, so that is a high energy wave. So the way you guys knew that the bottom one had higher energy is you have a lot of waves per second, right? Short wavelength, high frequency wave. Good. So like I said, this is something that we can actually calculate, okay? There are two factors that affect how much energy the wave is carrying. So waves carrying more or less energy have different blank and blank. So what was different between those two waves? One of them started with a W and the other one started with an F. What did I say was different between them?
Frequency.
Yep, good job. Definitely frequency and good job.
Wavelength.
Yep, thank you, AJ. Wavelength and frequency, okay? So wavelength and frequency are the two factors that are involved in the amount of energy that that wave is carrying and the speed of the wave. If you have a lot of waves per second, that's going to be a really fast wave, right? If you have less waves per second, low frequency, that's going to be a slower wave. So we have this magical equation of math, okay, science math, to calculate the speed of a wave. The speed of a wave is equal to wavelength times frequency, okay? In math, we like to represent that with equations, right? We love math equations. We love math symbols. So here is the actual equation, and I color-coded it for you. Speed equals wavelength times frequency. This pink symbol right here, that's actually a Greek letter, okay? In the Greek alphabet, that's lambda. You don't need to know all that, but it kind of looks like a wave, right? Like the shape of it's kind of like a wave. We use that to represent wavelength. So like it says in my little notes here, the S stands for velocity or speed. It's measured in meters per second. How many meters does it cover in a second? Wavelength is that pink symbol, okay, wavelength. It's measured in meters because it's a distance, right, the length of the waves. And then frequency, F for frequency, that one's pretty easy. And we learned last week that that's measured in hertz, okay? Well, why am I teaching you a math equation in science? Because we're about to practice doing this on today's worksheet. So speed equals wavelength times frequency. That's how we calculate the speed of a wave. Okay, so what I want you guys to do is go into your Schoology and we're gonna pull up this worksheet, okay? Wave calculations. So you can either go to 5th hour and go to today's folder, or you can click on it from your upcoming assignments. But I wanna give everybody a minute. Okay, I'm going to week of December 14th, going to Monday, and then you'll see wave calculations. I would like everybody to pull this up because we're going to look at the first couple of them together. Okay. So I'll give you another 30 seconds. Pull up this worksheet. Okay. So if we were in class, obviously we would write this out. We're not. So we're going to do a little bit of copy and paste, and then we're going to type in the numbers. You'll notice there are only 4 problems, okay? 1, 2, 3, 4. But for each of them, I want you to show me the equation, show your work, and your final answer. We're just going to type it, okay? If you wanted to, you could print it, but I would just type, okay? It gives you a wave, like the first one is about a guitar string, and then it gives you room to put the equation, show your work, and your final answer. So on number 1, it says a wave along a guitar string has a frequency of 540 hertz and a wavelength of 2.5 meters. Calculate the speed of the wave. Well, Miss Manrich just showed us the equation, or it's right up here at the top of the worksheet, okay? So I said copy paste from the yellow box above. The reason I did that is that wavelength symbol is kind of weird, but if you just go up and highlight that, okay, I know you guys already know how to copy and paste, but you could right click and you could push copy. Then you could go down to the box, right click again and push paste. I know there's other ways to copy and paste, but in case you didn't know, okay? So we have S equals this times this. So speed equals wavelength times frequency. Then we just go back to the problem and we find the wavelength and the frequency. So in the middle box, I'm going to say S equals, speed equals, and then up here I have my frequency, 540 hertz, okay? So I'm going to type that into my box. And I have my wavelength. You guys do not have to do the color coding. I'm just doing that to kind of show you a visual, okay? So I have frequency times.
Ma'am, this is already on it. I'm seeing this text already in for this.
Yes, that is probably because sometimes I write it in second hour on the original one, and then it's on yours. So that's a little extra present from me. I don't know. Okay, so let me still walk you through the steps, even if it's on your paper. When you go to do this, you're going to do the wavelength times the frequency, and you can even use a calculator, because I'm not concerned whether you know how to do that multiplying. I just want to know that you know how to calculate speed of a wave. Okay, so whether you have an actual calculator or if you pull it up on your phone, okay, however you're going to do it, we're going to plug in those numbers, 540 times 2.5, okay? So I want everybody to do that. I know there might be a little glare on my phone, but you can do it on your own calculator, even on the computer. And then type into the chat for me, what did you get when you did 540 times 2.5? Okay, who can tell us in the chat? Very nice. Good job, Chelsea. Good job, Trey. Okay, I'm just writing down some points for you guys. Yep, Amelia, correct. Okay, so I like where you guys are coming with joules because that's our energy unit, but when we're talking about speed of a wave, I'll tell you which unit we're going to use. So it's 1350. Oops, I always do that. I start typing in the chat. 1350, 1,350 is what we got when we did 540 times 2.5. And then if you look up in my little cheat sheet up top, the unit for speed is meters per second, whether we're talking about like a person running or a wave moving. Okay, when you're talking about speed, the unit is meters per second. Okay, so that's number 1. As you guys said, you actually had number 1 on your paper because Miss Mandridge always types on her original. We're gonna try numbers 2, 3, and 4, and that's gonna be what's due as an assignment. If you look, I actually made it due tomorrow because if you're still kind of processing this in your head, I gave you an extra day to make sure we get it turned in. But let's look at number 2 really quick, and then I'm gonna let you do 3 and 4 on your own. So I am gonna get my equation from up top. Okay, I'm just gonna copy paste that equation. And the reason I'm doing number 2 with you is we're actually gonna have to flip this around a little bit. So I wanna make sure everybody knows what to do. It says the speed of sound in air is about 340 meters per second. Okay, so, excuse me. So we know my speed is, I didn't copy paste. My speed is already figured out, 340 meters per second. Okay, then I have to say that that's equal to, I'm missing the wavelength. Okay, so whatever my wavelength is, times, oops, okay, times the frequency, and it tells me that the frequency is 490 hertz, okay? So I have 340 meters per second is equal to the wavelength, which is what we're missing, times 490 hertz. So use your math brain. In this one, I need to find wavelength. So I'm not gonna multiply, okay? What do I need to do with those numbers? Instead of multiply, what am I gonna do? Okay, good job, Trey. Yep, Chelsea's got it. I am going to divide. So I know it's gonna make me come up with like a funky decimal number, but I'm gonna take the speed, 340, divided by 490, okay? So when you go to do this, you can use a calculator, okay? 340 divided by 490, and then we get a long decimal number. We're gonna round that because this is science. We just want like our general answer, right? So we're gonna say 0.69, and instead of putting like the 38, I'm just gonna put 4. I'm gonna round up. So 0.694, and wavelength is actually measured in meters, okay? So there's number 2 for you. I'm going to stop my recording.